Graphing in standard form. In this video, you'll learn how to explain how the a and c value in y=ax²+bx+c affect the graph of the equation. You'll also learn how graphs, tables, and equations that represent the same quadratic function are related. So the standard form of a quadratic expression is written as a sum of ax²+bx+c. The value of c is a constant that represents the y-intercept of the function. So if we have these three equations that are in standard form, we can see how the constant, or our c value, represents the y-intercept in each of its graphs below. We can see that our first example has a y-intercept of -1, and the graph crosses the y-axis at -1. Our next example has a constant of 0, and we can see that it crosses the y-axis at 0. And in our last example, our constant term is 4. And we can see that it crosses the y-axis right at 4. If we go back to our standard form of a quadratic expression, we can see that a determines the width and the direction of the parabola. This is the parent function of a quadratic expression of y=x². If our a value is negative, then it turns our parabola upside down. If our a value is larger than 1, in this case we have 2, it's going to shrink our parabola. And if our a value is less than 1, like 1/2, then it's going to stretch our parabola. So let's look at some examples. We're going to match each quadratic function to its graph. Our first example of f of x equals x² - 4 has a constant term of -4. And we can see that the graph of b has a y-intercept at -4. So this must represent function b. Now let's look at g of x. First, let's put it in standard form so that our x term comes first. Now we can see that the a value is negative, so that's going to turn our parabola upside down. We can see that c is the only parabola that's upside down, so function g of x must match graph c. Now let's look at h of x. We know that it must be graph a because that's the only one that's left. And a has a y-intercept of +4, just like h of s suggests. So this confirms that a is our graph. Now let's look at another example. The two equations f of x equals x + 2 times x + 3 and g of x equals x² + 5x + 6 are equivalent. Which equation helps us find the x-intercepts most efficiently? Well, we can see that f of x is in factored form, and factored form always gives us the x-intercepts most efficiently, so f of x would help us with the x-intercepts. Now, which equation would help us find the y-intercept most efficiently? G of x is in standard form, and standard form always tells us that the constant is our y-intercept, so g of x will help us find the y-intercept. In this example, the graph shows y is equal to x². On the same coordinate plane, we're going to sketch and label the equations below. Let's start with x² - 4. We can see that it has an a value of +1 and a constant of -4. So our graph will have a y-intercept at -4, and the parabola will have the same shape as y=x² since both a values are 1. Now let's look at -x² + 5. Our a value is negative, so we know that our parabola is going to go upside down. And our constant term is 5. So we'll put our y-intercept at +5, and then draw our parabola upside down. Let's look at one more example. Which of the equations below have positive y-intercepts? Let's start by looking at those that are in standard form, since these have y-intercepts a lot clearer. In our first example, we see that our y-intercept would happen at -2. So this one isn't positive, so we'll cross this one out. Now let's look at y=x² - 10x. We would really have a constant of +0 since nothing is there, but since 0 is neither positive or negative, this one won't be one of our solutions. Now let's look at our last equation in standard form. It has a y-intercept of -5, so since it's negative, we'll cross this one out as well. Now let's look at our two remaining equations that are in factored form. X - 1 squared is the same as multiplying x - 1 by itself. So we'll distribute the first parenthesis to the second parenthesis. This will give us x times x - 1 minus 1 times x - 1. And we'll get x² - 1x minus 1x plus 1. So we can see that our constant is +1. So this does have a positive y-intercept. Now let's look at our last one. So we'll take our last one to expand it, and we'll distribute the x plus 1 to x plus 2. So we'll get x times x plus 2 plus 1 times x plus 2. This gives us x squared plus 2x plus 1x plus 2. And we can see that our constant is positive 2. So this one also has a positive y-intercept. Now let's summarize what we've learned. When given a function in standard form, the value of a tells us the width and direction of the parabola, and the c value of the function will tell us the y-intercept.